Welcome back to our Explainer series. So last time, we established that an AI agent is a system that pursues a goal. Planning, using tools, evaluating results. But today I want you to imagine giving an AI this massive instruction. Research the global AI agent market, analyze 50 companies, read dozens of reports, compare their products, identify market trends, create charts, and prepare a 20-page strategy report. We are literally talking about hours of autonomous work. Okay, let's dive into the structure for today. We'll start with the concept of the long-running agent, figure out why long tasks are just so hard to pull off, and look at how agents manage to stay on track. Then we'll check out agents in the real world and wrap up with the future of delegation. All right, part one, the long-running agent. We're moving way beyond quick chatbot interactions here into a totally different paradigm. So here's the central question, right? Can you just drop a massive prompt into the system, walk away, leave the AI running for several hours, and then just come back to a perfectly finished product? Honestly, it sounds incredibly simple. But making an agent actually work for a long time, it's not just about keeping the model turned on. It is a completely different technical beast. Let's define what we're really talking about here. A long-running AI agent is a system specifically designed to execute a really complex objective over an extended period. And the core capability here isn't time. It's not about the clock ticking. It's about maintaining reliable progress over a massive workflow. I'm talking about maintaining its progress, its context, its state, and its memory across literally hundreds of actions and dozens of tool calls. And this brilliantly illustrates the contrast. Look at a short task. It is wonderfully linear, right? Goal, plan, actions, result. Boom, done in seconds. But look at the long task. You start with a goal, break it down into subtasks, execute, save your progress, observe the results, recover from any errors, continue, replan, verify. It's this massive looping ecosystem of complexity. Which brings us to section 2, why long tasks are hard. Let's look at the harsh realities of extended AI execution. These right here are the true enemies of long-running tasks. First up, context bloat. An agent can generate so much information that it literally just blocks up its own context window. Then you have state amnesia. That's when the AI completely loses track of what it's already finished versus what it still needs to do. Plus, let's face it, external tools fail. Websites change out of nowhere, APIs time out right when you need them the most. Add in the very real chance of the AI generating incorrect results, which then leads to this cascading avalanche of bad decisions, and suddenly you're looking at skyrocketing execution costs and latency. I just want to pause here for a second and really let this core realization sink in. Every single additional step creates another opportunity for something to go wrong. Think about it. When an interaction takes 2 seconds, your risk is practically zero. But when a task demands hundreds of actions across several hours, the math totally turns against you. Long tasks are fundamentally harder because they literally multiply risk. So, how do we fix this? Section 3, how agents stay on track. Let's look at the engineering architecture that actually solves these problems. Okay, I want you to imagine you're writing a 500-page report and you never ever hit save on the document. If your computer crashes on page 490, you lose absolutely everything. You know that visceral panic you'd feel? That is exactly what happens to an AI system if it doesn't have built-in save points. So the absolutely crucial point here is this recovery loop. Long-running agents desperately need the equivalent of save points, what engineers call checkpoints. Basically, the agent gets a task, does some work, and creates a checkpoint. This checkpoint locks in the current plan, the tool results, and any errors. So if something breaks, the agent just goes into a recovery phase and continues from that last checkpoint, instead of having to restart the whole shebang from zero. Now, what's really interesting about this slide is how it disambiguates 3 very critical terms that a robust agent has to juggle. First, context. That's the information available for the current decision, like, say, the financial results for company B that it's analyzing right this second. Then there's memory, which is information retained and reused later, like knowing it already finished company A. And finally, state. That's the current condition and progress of the entire task, like knowing it's currently 40 companies through a list of 50. So what exactly happens when the agent inevitably runs into a wall? Say it's researching that list of 50 companies, and company number 27's website just goes down. Now, a weak system, it crashes. But a robust, long-running agent, it detects the failure, and then it gracefully handles it. It'll retry the action. If that still fails, it tries an alternative source, it records the problem, continues with the remaining tasks, and then simply returns to that failed task later on.
And that leads us to what I honestly think is one of the most profound aha moments of this entire explainer. Reliability is not the absence of failures. Reliability is the ability to handle failures without losing the entire task. We really have to reframe how we think about AI's success here. It is not about being perfect. It's about being resilient.
Let's look at how this plays out in practice. Section 4. Agents in the real world. Thanks to this kind of checkpointing and state management, agents are already starting to act like autonomous workers across different industries today. In software engineering, an agent can investigate a bug, tweak the code, run tests, and iterate on failures all on its own. In research, they're scouring massive source lists, organizing findings, and spotting knowledge gaps. In data analysis, they're exploring entire datasets, writing the analysis code, and fixing their own errors on the fly. And in business, they're out there researching competitors and drafting strategic briefings. But hey, let's ground this in reality for a second to avoid the marketing hype. What is actually possible right now? Multi-step workflows using specific tools and careful orchestration. What is still difficult? Completely unsupervised, highly reliable, totally open-ended work for very long periods. We are definitely making huge strides, but we're still building toward that completely hands-off future. Which brings us to our final narrative arc. Section 5, the future of delegation. We are undergoing a massive paradigm shift here. We're moving from viewing AI as something you talk to into viewing AI as something you delegate work to. That traditional interaction where you ask a question, the AI responds, and you decide what to do next, that's fundamentally evolving. Very soon, we'll simply define overarching objectives, and agents will execute massive, multi-hour workflows to achieve them. But don't worry, humans aren't disappearing from this loop. Let's move to more and see how this builds a whole new role for us. Our job is shifting heavily toward management and oversight. We're going to be spending our time defining those overarching objectives, setting the rules and constraints, approving the truly critical actions, reviewing the final results, and really only stepping in to handle those super complex exceptions that the agent just can't figure out. So, to summarize the core thesis of this explainer today, the next major challenge isn't just making AI smarter. It is making AI capable of staying on track, maintaining progress, managing context, and recovering gracefully. Those are the true next frontiers of AI engineering. But that leaves us with a massive open question, right? Think about it. If an agent is running for 6 straight hours, doing research and writing code, it's generating gigabytes of data. So what information should the agent actually see at each specific step to avoid getting totally overwhelmed? Well, we are going to unpack that exact cliffhanger in our next explainer on context engineering. Until then, stay focused and keep learning.